Okay, let's have a look at example 2. It says, examine the behaviour of this function as x approaches plus or minus infinity. Now, we know that means algebraically we look at the limit as x is approaching plus or minus infinity of the function. And that might be all the question requires. However, this is often a precursor to drawing the sketch of. So part 1 might be examine this behaviour, part 2 draw the sketch. We might actually draw the sketch so that we can see this process actually working in a practical situation. Now, it's no surprise that we've got a function which is an algebraic fraction, and we're going to use the special limit that says the limit as x is approaching plus or minus infinity of a 1 on x will always result in a 0. So we'll be setting about to create some 1 on x's within this fraction, and the way that we'll do that is we will divide through by the highest power of the x in the denominator. Once I've got that set up, then I'll be applying the limit, and I'll replace all 1 on x's or 1 on x squareds with a 0. So we want the limit as x approaches plus or minus infinity of, and of course the highest power in the denominator is the x squared, minus 5x on x squared minus 3x squared on x squared. Okay, simplify will be 3 on x squared. Now, if 1 on x goes to 0, when you apply the actual limit, which we will do probably in the next line, then certainly anything on x squared will also go to 0. Minus 5 on x, that will clearly go to 0, and we'll have minus 3 here, all over 4 on x squared. When we apply the limit that x is infinity or negative infinity, that whole thing goes to 0. Minus 5 on x minus, sorry, where did I get that 3? That should have been a 4 there. My mistake, sorry. Minus 3. So we're at a position now where we can actually apply the limit. So I don't write it, I'm actually applying it. I'm saying that would be a 0, that would be a 0. We would have minus 4 over minus 3, which is actually 4 on 3. So it's indicating that as you approach plus infinity for x or minus infinity, the y values are getting closer and closer to 1 and 1/3. So if this is my 4 on 3, I'm going to have a horizontal asymptote here at 4 on 3. It's quite a bit more work to do before we can actually sketch that. So I'm going to actually pause the video and do a little bit of work on identifying the points of discontinuity, and once we've got that established, which will be our vertical asymptote, then we can work on the shape of the actual graph. Okay, I've done a bit more investigating of that graph, and it actually has what we would call an oblique asymptote, so we're not going to pursue that graph anymore, and you in this course will certainly not be expected to be able to do that.